Hi, I'm Scott Snelling, the CEO of Roebling Labs. We deploy vessel collision warning systems for vulnerable bridges. I have 25 years experience in the bridge industry, and our Chief Technology Officer, Josh Burnett, comes from the medical device industry, where he has 25 years experience designing software and electronics for life safety critical devices, which is what we've built here. To start with the problem, in the aftermath of the Francis Scott Key Bridge collapse, the National Transportation Safety Board made recommendation H2530 to for owners to incorporate motorist warning systems, or what we call vessel collision warning systems, capable of activating when a vessel collision threat is identified. This impacts 68 different bridges across the U.S. that NTSB identified as similarly vulnerable to Francis Scott Key, owned by 20 different owner agencies. If you own one of these bridges, there's a real cost to inaction. You can calculate the annual frequency of collapse, which you're required to do per AASHTO, and as well as estimate the life loss per collapse and the value of a statistical life. If you do that for most of these bridges, it's in the millions of dollars per year in annual life loss cost if the owner does nothing. So our solution, we've developed a vessel collision warning system. This is a simple schematic that shows how the system works. Since 2002, the U.S. Coast Guard has required all ships to carry AIS transponders, as well as not just the Coast Guard, but globally as well. Uh, that packets of information are sent from the ship as often as every 2 seconds, carrying critical information about speed, location, rate of turn, speed over ground, et cetera, et cetera. And the system was primarily designed to avoid ship-to-ship collision when there's low visibility. But it has all the information we need to assess ship-to-bridge collision. We have a hardware unit that we can mount on the bridge or near the bridge. The radio signals travel about 30 miles, and we gather them directly from the ship. We send that information up to the cloud where we perform real-time risk assessment, and then we present that to the bridge owner using a real-time dashboard. In their either their traffic control center or security operations center. These are places where bridge owners tend to staff 24/7, 365 days a year, and ready to respond quickly to emergent situations. They can take life-saving actions, such as evacuating the bridge by operating traffic gates, by calling on a marine radio to the ships that may be aberrant, or sounding the foghorn on the bridge. And this can all be done remotely. The staff does not need to be at the bridge site. So again, just to show how that real-time threat assessment works, on the left shows that raw code that we get from the AIS transmission. Each line is a different transmission, and we decode that. On the other end, we provide we analyze for both the probability that the vessel is aberrant and the probability that it could collide with the bridge, as well as the consequences if such a collision was to occur. Would the impact forces be great enough to risk bridge collapse or not? Um, but these aren't just ideas. We have working systems that currently deployed on 4 different bridges that are on the NTSB's vulnerable list. 3 are owned by the New York State Bridge Authority. They have 3 bridges on the list, and our system's currently operating on all 3, as well as the Newport Bridge, owned by the Rhode Island Turnpike and Bridge Authority. There are systems operating there, and that bridge is on the list. So if your agency or if you're an engineer whose client agency owns one of these bridges on the NTSB list, you have a few different options. You can do nothing, but there's life loss costs of excess of $1 million per year. You could replace the bridge, but that likely would cost $5 billion and take 10 years. These are long span bridges over ocean channels, so they're not small, fast projects to do. You could retrofit the bridge with fenders, dolphins, and other pier protection. systems, but these types of projects typically cost about $100 million and take 5 years to do, and oftentimes just deliver a partial solution. So for that reason, a vessel collision warning system is a really great option to mitigate the life loss risk at your vulnerable bridge. We can install the system in 1 day or less, and it costs an order of magnitude less than the do nothing option. So contact us. We'd love to give you a demo of our system. We'd love to start with a pilot project where we can install our hardware on your bridge and show you how the system works at your site. So thanks for your time.